Good afternoon, everyone. Welcome to Project TAC 9, and we are Team Costicon 4A. The agenda today will be that we'll start with challenge summary and user stories, followed by solutions, continuing with future development, and completing with Q&A. The team today is made up of Shakil Mahmood, Mustafa Kamal, Lubna Salem, William Shepherdson, John Lowe, and Juil Elmos Floros.
Our challenge is to create a tool to flag potential concern based on historical forecast and actual cost data. Output will be to create a dashboard to display the relationship between tender and actual cost, a predictive cost model preparation, and a recommendation on future development. Benefit will be statistical insight to key cost areas of concern, early warning to potential increase in cost to mitigate risk, and insight to future proof of the possibility. User stories. As a project manager, I want to see who had the greatest cost exposure in my budget forecast so that I can address and mitigate the risk. As a tender manager or estimator, I want feedback on the accuracy of my tender so that I can improve the pricing of my tender and potentially win more work. As a project finance business partner, I want to see if the forecasts are in an acceptable range of variance so that I can better manage project profit margins. Our solution started with determining the end result requirement, early gap analysis of the requirement, some data analytics, and then final products visualization. So in doing that, we have used Python, Excel, Power BI, and Pandas.
Having reviewed the problem statement, as well as the data available to us, we soon realized that one dashboard wouldn't go around giving you the best insights into your data that you could hope to get. And it was at that point we set about creating 4 separate dashboards. The first, being the main overview page, is based around that component family, that higher level that gives you that insight of where you might, in that first instance, need to focus in on. We then went a step down and looked at component types to give that more granular level of interpretation as to kind of where your real potential problem childs are in regards to variance, be that as a percentage value or a pounds value. Outside of that, we then looked about setting a comparison between the pounds and percentage to give you that full rounded picture of where you do and don't have potential issues. The last dashboard, and probably the one most useful on a day-to-day basis, was the component comparison selector. This enables an end user or kind of estimator, project manager to go through, select specific component families or even component types, and create a list that will then clearly identify to them where their kind of tender cost is, to kind of what historic actual costs might be, giving that sort of overview of what that variance is, including conditional formatting, color coding, to understand if it's dramatically over or under where they need to be.
Continuing on, we train the linear regression algorithm based on the family of the components that the user selects. The regression line is fitted based on the historical data of the actual cost equipment and the tender cost equipment. Therefore, by putting as an input a new tender cost for a component, it predicts its actual value. We tried a variety of regression models, such as multinomial and decision tree regression models. However, due to the lack of much data, as our largest dataset of family was consisted of 36 rows in 2 columns, we decided that for this moment, the linear regression is the best fitted model. In the future, by enriching our dataset, a more accurate model can be developed, such as a multi-layered neural network model. Afterwards, we generated a dashboard in Power BI where we developed a linear regression model and in which we upload the historical data of the product that we want to examine from the Excel file. Then the user can select the tender cost and see the predicted actual value as well as the error percentage of the selection based on the forecasted actual value of the regression model. Continuing, this error is contrasted with the threshold error defined by the user in the Excel file. If the predicted error is exceeding the threshold, then the result of if the tender cost input is accepted or not is being shown in the code's figure.
Looking back at our user stories and grading ourselves on how successful our solution was at meeting the user requirements, we have mapped out how bringing in greater amounts of data would help unlock the capacity to provide deeper insights, such as by analysing regional cost impacts to create heat maps, which can act as a further early warning tool. To fully meet our final user story requires productionizing our chosen tools. Using Power Apps, future developments could include creating automated reports analysing likely cost variances for a new tender, utilising a centralised database. Additionally, further development of a predictive model in Python would yield further insights. Provided with the tendered and actual test and assembly hours, we took an assumed base rate to analyse the cost impact of overrunning on TNA hours. We have used this to show users how the TNA overrun impacts on the total cost overrun. This is an example of the greater level of analysis we could do with further data, and shows how we could begin to investigate the reasons for the cost variance, giving users greater power to mitigate the underlying risks.
So in terms of question and answer, the first question we're posed with is, what other types of data could you use to improve your budget forecasts? The answers we came up with are A, greater volume of real-world data from both BH and others. B, data associated with costs, i.e. tender data, actual data time lags. C, additional reference points, including quotation negotiation roadmaps. D, project specificity related to costs, i.e. which equipment relates to which projects. E, geographical location, i.e. the impact on costs, for example, if you're operating in countries with restrictions. And F, market data for comparison with specific vendors utilized in actuals or tenders. The second question we're posed with is, when it comes to solutions deployment, how would you get the latest data loaded into your solution? The answers we came up with are, firstly, replace the Excel spreadsheet with either a SharePoint list or an SQL table. The second answer is automatically collating the data from original storage sources to singlet database, with the caveat that if the database does not exist, a Power App can be utilized to input the data. The third question we were asked came in two parts. The first part was how much legacy data can be used to improve your forecasts. The answer we came up with is this is dependent on data validity and acceptable business lag. Suitable data volume requires to be expanded by a factor of 5 in comparison with the current data provided. The second part was the question, is the data you have granular enough to achieve what you need? The answer we came up with is the data available allows for high-level statistical insights and assumption stroke analysis. But to truly unlock the value, additional granular data is required, such as full test and assembly, including variations in hourly labor rates. Thank you very much.